All right, we're going to go ahead and get started here. Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about Industry 4.0 and impacts within the machine builder industry. At Visual Decisions, we've been in the business of utilizing information from the shop floor and from products to improve performance since about 2002. We help our customers combine the smart factory and the lean factory, as well as smart products, to drive improvements to cost, throughput, quality, and revenue. Our customers have seen dramatic improvements, such as 30% increase in OEE, 50% scrap reduction, and much more. Let's see, as I said, today we're going to talk about machine builders and challenges that they face. And the very first thing is that customers are expecting smarter equipment these days. I've worked with a number of different customers that do things such as 3D printers and so forth. And if you think about certainly an advanced machine like that, customers are expecting information coming from that so that they can diagnose the performance of it, whether it's going to have a failure, etc. And if you think about smart manufacturing, Industry 4.0, Made in China 2025, all of the different initiatives that are out there across all of these different groups, there's just a huge number of possibilities that customers are expecting from their machine vendors at this point. And so if you think about those things in a little bit more detail, it's connectivity for improved asset utilization, it's operational intelligence, it's getting those big changes in throughput and reductions in scrap and rework and so forth, reducing the production risk, lowering the cost of ownership, and then being able to tie this into a broader ecosystem. So number of different customers are implementing systems to really manage their shop floor to get these improvements not only from your machine, but really across all of the different machines in kind of a heterogeneous environment here, where they have different vendors, different processes going on, and they want to be able to tie all of that information together. The other thing that they're looking for is value. So it's not only producing parts anymore, it's being able to provide that value-added services and so forth that are going to help the customer get the most that they possibly can out of that machine. And so price is definitely important. Price will always be important, but it's not necessarily the only factor that's going to drive decisions on which vendor they go with. And features and benefits of producing those parts themselves may not be enough anymore. So just a few high impact use cases, but before I get too far along here, I do want to say that if you have questions as we go through this, please enter them into the Q&A, and I'll either answer those as I go if it's something that needs clarification, or I'll circle back to it at the end. And I also want to say that this is being recorded, and that the recording will be available on my website afterwards, as well as the presentation itself will be available for download from my website at visualdecisions.com. All right, so with that, let's get into the high impact use cases here. And if we look at product connectivity, being able to simply establish that live connection into your machine, that itself is going to be something that customers will find very valuable, because that's kind of the base enabler to everything else that follows. And that connectivity can be established in a number of different ways. We'll get into that more as we go through. But what you're looking for is a broad spectrum of edge connection options so that you can easily add those to your system in different environments. flexibility to work with any different architecture or product. So no matter what the customer is using within their environment, having the ability to establish that connection to what they're doing. Rockwell is a very common tool out there, so there's native integration with that and so forth, as well as to the Microsoft Azure Edge and IoT Hub. And there are tremendous savings available from these types of systems. And I guess I should say that normally I do these presentations from a very agnostic point of view. Within this space, I do find that PTC is a leader within the area and within the industry. And so I'm going to be talking about PTC solutions throughout the day. There are other ways to go about this that I can talk to you about if you would desire, but I do recommend PTC in this space very heavily. So once you have that connectivity established, some of the things that you want to do with it, one of the first is condition-based service. And so being able to proactively notify your customers when, before the machine fails, but when it requires service. And so if you think about condition-based maintenance within, your own operations, what you're looking for when things start to go out of tolerance, whether that's, a temperature or vibration or, anything else, you're just monitoring the equipment to detect certain conditions. And when those conditions occur, then you schedule maintenance for, different activities. And being able to provide that capability to your customers is a definite value add service that you can provide. And so this gives you that out of the box alarm and alert definition, notifications through a number of different channels, whether that's text message, email, any other kind of alert that you can imagine. And again, tremendous cost savings and efficiency gains that can be made with this. Another way that you can do this is not as IoT centric, but it's more AR centric and so forth. So it's providing assistance for customer self-service and technician support. And so, how do you link up the customer to an expert so that they can, diagnose and fix the equipment without sending a repairman out there? Or, if the technician goes out there, how can you make sure that they're tied to, the best experts that you have in the company so that they can get it fixed the first time? And, being able to, provide that, AR support for those people in the field is it's game changing in terms of what can be done to improve the first time fix rate, how many, repairmen you have to send out in the first place, and the amount of downtime at the customer can be dramatically reduced this way. So the condition based was looking at mean time between failures, and this is looking at the mean time to repair. So then, the first one was getting them hooked up live with an expert. This is AR to provide expert guidance in the form of work instructions and so forth, and being able to have your experts record those and then have those available for predetermined conditions that need to be addressed. And this could be something like routine maintenance and so forth, changing filters, etc. That you have that information available in a library for your customers, for your technicians to be able to utilize. All right. So looking at those connected product solutions that are provided from PTC, it really breaks down into three separate categories. At the center, you have the product intelligence and getting that connectivity established, pulling that information over the web into the cloud, and then being able to put the analytics behind that to have the intelligence to do something with that data. And then it's looking at the service side of things and being able to optimize the service equation. And then it's also product innovation and how can you actually drive additional revenue utilizing these capabilities. And so breaking that down a little bit further, on the service side, you have remote service, where that's looking at the, being able to analyze the information remotely and perform the predictive and condition-based service. Looking at customer self-service and how do you enable that with enhanced instructions and also that remote support. And then the field technician efficiency, how do you reduce the number of times that you send that person out? How do you make sure that when they go out there, they fix it right the first time? And then from a product innovation point of view, it's really, how can you establish some additional, revenue models utilizing this, where you have those service or value add capabilities that you're providing to the customer. And then from a design perspective, how do you take the information of usage in the field and incorporate that back into your manufacturing process so that you can make things better in the future, as well as being able to take that and all the way back into your engineering process and utilize kind of that telematics information from the field in your product design so that the next generation of the product can be even more valuable for your customer. So to do this, what you're really trying to do is to increase that service profitability, reduce the cost and increase customer satisfaction, make time on site more productive and spend less time on site. And then also grow sales and improve your product design. So with those three different areas, we're going to dive into those in a bit more detail. So we'll start off with the product intelligence. And from a product intelligence point of view, what we want to do is we want to provide connectivity. Start there again, that's kind of the launching point for all of this. Provide simple integrations, have that capacity to pass that information to the customer, but then also provide a richer context around all of this information, whether that's actually getting information from the customer and integrating that into the picture of what's happening on that machine, maybe grabbing schedule information, part number information, et cetera, as well as being able to integrate that back on your end and being able to provide context for you guys interpreting that information of the machine that you're providing to the customer. So looking at additional information about how that was built, how this machine is functioning at other locations, et cetera, to be able to show the data for that particular machine within an overall context. The real-time monitoring is obviously very important in terms of being able to establish the additional capabilities. The condition-based service, as I talked about earlier, is just being able to look at what's happening in the machine and triggering those alerts and alarms and so forth. Looking at product performance KPIs, how is your machine performing out in the field? Is it going as expected? Are there things that are coming up that are going to be value add above and beyond for the customer than what was expected? Or is it something where the machine is not performing as expected and maybe you proactively work with the customer to get the machine performing better? And then it's also that augmented remote assistance to be able to provide the additional level of support to your customer. So from a connectivity point of view, what we want to look at is how do we actually establish communication with that machine? And the first thing is that there's a spectrum of edge connection options available, whether those are utilizing the PTC Kepware server, and there's an edge version of Kepware that's available for installation within the machine itself, or utilizing something like the Azure IoT Edge and so forth. A number of different ways that we can actually talk to what the machine and gather the information from the machine. And that works with both new equipment where you're designing it from the beginning to have that connectivity established. And it also works with existing equipment where we can put a gateway device out there that talks to the different machines and then passes that information back up to the cloud. From an integration point of view, once the information has been gathered from the machine and up to ThingWorks, now you have a tremendous amount of integration capabilities available. There's low code solution for establishing those different integrations. You have the ability to bring contextual information from the customer if they allow that, or additional information from your own data, so that you can provide additional context for your interpretation of that information coming from the machine. The real-time product monitoring, once you have that connectivity established again, and you have the information streaming to ThingWorks, you're contextualizing it with data from the customer, from your own information and so forth. Now you have the ability to establish that real-time product monitoring and establishing those alerts for at a glance information, being able to look at the uptime and downtime across all of the different machines that are out there in the field. Looking at the use case information and how the machine is actually getting used. Is it at 100% utilization at the customer? Do they have it scheduled 24 hours a day? Do they have it scheduled one shift, two shift? Because a lot of that different information is going to make a significant difference in how you interpret the data coming from there. So even if it's something like a machine that's cutting metal parts, and you might have kind of the same, they're both cutting screws, but the hardness of the different screws and so forth can make a big difference in terms of the performance of the machine, and so forth. Not to mention, what tooling is in place, everything else. And so there are a lot of different factors that come into looking at that performance of the machine, and that's why you need that additional contextual information if you can get it. That helps you, properly look at all of this different data that's coming in. But you have tremendous amounts of flexibility in terms of what you bring in, how you analyze it, and the level of intelligence that you build into that solution to interpret what's going on. The condition-based service is really just, again, looking at those detailed process variables and how they're changing throughout the operation, tying that into output variables where you can get hold of them. As an outside vendor just looking at your machine, you really don't have a view of downstream quality, but if you have some idea of what the condition of those pieces is coming off of the machine, then you can do much more in terms of tying that back into those process variables and so forth. But you can also look at full predictive capabilities, going beyond just the condition-based monitoring and looking at how do we run these process variables through the machine learning algorithm to be able to say when we are predicting that failure is going to occur, even though it may not be beyond the tolerances that would set off a condition-based service ticket yet. Going back to the integration, one thing that I forgot to mention is that as you're looking at that integration, one of the things that you can do is, if you see the tolerances, the performance outside of tolerances, as you're doing your condition-based monitoring, one of the integrations that you could have is, kicking off a work ticket to actually now go do something about that. And so you can, look at the integration to your own service offering and whatever you use for managing service out in the field, or you can actually kick off a ticket to the customer's own maintenance management system, or both, depending on how you would like to establish that workflow with your customers. And finally, going through this section of it, the augmented remote assistance, as I mentioned, is something where as your customer or your own technicians are looking at that product, what they can do is they can make a call back to an expert and have that expert now give them instructions for how things are going to work. And as you can see, The expert, as the technician or the operator has their camera pointed at the machine, the expert can actually make annotations and so forth right on the display. And then as you move the camera, the annotations will actually stay in place, where they were drawn on the machine itself. And so it's very, helpful for being able to, get that expert assistance in a meaningful way out to the field. So going into a little bit more detail beyond just that remote support, if we look at remote service as a whole, the first step in that is actually the remote diagnostics. And so a few weeks ago, I ran a series of webinars on maintenance where I talked about breaking down the components of mean time between failure, mean time to repair, and first time fix rate, and how you actually go about optimizing those in a way that takes that holistic approach. And remote diagnostics was a very important part of that, because when you look at the mean time between failure, certainly being able to have these diagnostics in place means that you might be able to, instead of doing regularly timed maintenance, changing your oil every 3,000 miles, you can actually monitor the number of particulates in the oil and things like that, the viscosity of the oil, see when that changes, and be able to now say that when that gets to a certain point, we're going to perform the maintenance to change the oil. But remote diagnostics also helps when you do have a failure out in the field. If you have those remote diagnostics in place, when I send a repairman out to the machine, I can actually arm them with this information in advance that allows them to be prepared, bring the right tools, bring the right spares and so forth, so that when they get to the machine, they can fix it on that first visit, rather than going out there to do the diagnosis and then having to come back to make the repair with the right tools and spares and so forth. And so those remote diagnostics are critical for both improving your mean time between failure, and as well as doing the minimization of your mean time to repair and optimizing your first time fix rate. The remote access and control, if you have the ability to, go to the machine itself and, get those diagnostics in place and so forth, and then being able to, give the customer the information on, things that they can do themselves and so forth, that will certainly, help minimize the amount of times that you have to send a technician out there. There's also capabilities around remote software management. So if you have software elements to your machine that's out in the field, you can utilize these capabilities to manage that software as well. And then certainly from a predictive service point of view, as I've mentioned, it's taking those condition-based monitoring solutions to that next level, running them through the machine learning algorithms, and putting the predictive capabilities in place so that even before you go outside of your controls from a condition-based point of view, you can start to predict when you have those upcoming failures. Let's see. So next, if we look at the customer self-service, and how you can avoid having those truck rolls in the first place. It's looking at a lot of augmented reality capabilities here. So again, having that remote assistance capability, 3D work instructions, expert guidance, and then product intelligence from a user point of view as well. And so this is the exact same thing that we looked at earlier, but specifically for the customer, and how we provide the customer those expert capabilities from a remote person. The 3D work instructions are something where you can have your internal experts look at common either common failures and repairing common failures, or some of the common just autonomous maintenance type functions, replacing filters, etc. You can have the experts record those things, using a HoloLens or something along those lines, RealWear, etc., and annotate those things. Have those work instructions be available, and actually show the video of them performing those tasks, as well as annotations for safety and things like that, that allow you to pass that information to the customer, have that as another value add differentiator for your product, and really boost the amount of things that the customer can take care of on their own. What I've seen done is to combine this with a product FMEA, and just kind of walk through that FMEA for what are the most common failure modes, as well as what are the highest RPN failure modes, and start to put those expert instructions in place for what to do for each one of those different failure modes. And then over time, you can basically have that complete set of instructions available for your customers. Oops, sorry, skipped ahead. The augmented expert guidance is just kind of taking that same thing to that next level, and providing that expert capture and those expert instructions for the customer. And then product intelligence is really just having that capability that the customer, in addition to your own company, the customer can now get visibility to how that machine is performing within their own company. And so this is still looking at that overall information that you have up in the cloud, but looking at only those things that the customer has access to. So what are the machines that they've purchased and so forth. Right. So from a field technician point of view, and how do we make those field technicians more effective? It's many of those same things, plus some of the service parts management, the service process integration and automation and so forth. And so I'm not going to spend a whole lot of time on the augmented remote assistance. These are things that we've talked about before, but it's being able to see what's going on, have the expert annotate that screen, and have those annotations stay spatially in place as the camera moves around. The 3D work instructions I've covered, but those are applicable for the technicians out in the field as well as the expert guidance, and being able to get all of those instructions out there. All right, the service process integration is something where you can establish service requests, and this goes back to the integration that I talked about earlier, where your own service systems and so forth, you can establish the integration between the product monitoring that you're doing, and then tying that back into your own service capabilities, and automate that process of passing information back and forth, creating tickets, etc. And service parts management is something else that is provided as a capability from PTC to look at forecasting accuracy, to look at where you want to keep the inventory, not just how much, but where you want to keep that inventory, and then how do you improve service levels, availability, et cetera, as well as having that outstanding demand forecasting in there. Let's see, on the product side, if we start to look at the connected revenue models, how do you establish new business models with this? Automated consumable sales, capacity-based upsell and cross-sell and so forth. And so when we look at some of these new business models, being able to increase revenue and revenue stability, expand the addressable market, increase customer satisfaction, value-based pricing, et cetera. Really what it comes down to is, how can you win more business with your existing product line? Because now you have these additional differentiators, against your competitors and so forth. And, sometimes it's just saving your position in the market, because, some of these additional capabilities are simply becoming table stakes for, even having, market share whatsoever. You're going to lose it if you don't have these capabilities in many cases. But it's also, how do I take, all of those things that I've just talked about from a service point of view, product intelligence point of view, and so forth, and now, have that as value add that I can sell on top of my product, out to my customer as a service that, I provide as a vendor. And so those are, different things that you can do to, create those new business models. And then, you can also have automated consumable sales. So I have a customer that, sells, products that, require filters. And what they do is they monitor the usage, they monitor, the quality of the water passing through those filters and so forth. And they're able to now automate the shipment of those filters out to the customer. And, basically, they're not subject to as much competition that way. They just have it basically as a service contract with that customer. And they're just automatically sending those filters out when they're required, rather than having to wait for, a PO coming in each time or an invoice coming in each time, and so forth. So then you also have capacity-based upsell and cross-sell, where I have the ability to help my customer really utilize the capacity to its fullest, and then kind of cross-sell some of the different capabilities that I have from an analytics point of view out to the customer. Now, one place that I've seen this is that for a customer that has their machines and a lot of different customers, they collect information from all of those different customers, they genericize that information, and then they basically sell that information back to their customer base as industry data. And they obviously get agreement from all those customers in the first place to participate within that. But you can't buy the information unless you're sharing your information as well. And so they make sure that it's fully genericized and nobody can tell where the data is actually generating. But now as a customer, I can see how's my machine performing relative to other people in the industry. And I can start to see where I may not have best in class maintenance practices, things like that. From a data-driven design and taking this information and pulling it back into my design process. So from a connected product management, if I look at the product lifecycle management and so forth, being able to take the data from the field and being able to store that within my or at least access that within my PLM system. What I can do is I can start to incorporate that telemetry, into that design process to generate new design options and look at what are the features and functions of that product that are being most heavily utilized. Where do I think that there's room for growth from a performance point of view at the customer? Where do I see, constraints in their usage of the product? Where do I see, downtime that needs to be addressed? Any number of different things I can pull in from a product management point of view and perform analysis on that data to be able to say, here's where I need to be with the next version of my product. And then it's also validating, that information and being able to monitor those products for quality failures, deviations. If you think about warranty data, out in the field, and warranty claims, and being able to look at some of this telematics data and being able to certify that the product was used as it's supposed to. If I'm GM and somebody purposefully ran their car into a wall, well, maybe that isn't a valid warranty claim, kind of a thing. But being able to get this information is only going to help you from being able to improve your product quality, improve customer satisfaction, but also kind of validate some of those claims that are being made and being able to manage that information. So with that, That's the end of the presentation. I thank you for your time. I don't see any questions in the Q&A, so what I will do is I will follow up with each of you individually, and I'll reach out to you. But if you haven't heard from me and you have questions, please reach out to me at tim@visualdecisions.com or 630-957-8096. Happy to take your call, and reach out to me anytime. Thank you very much for your time this morning, and have a great day.